Dopamine is a neurotransmitter, a small molecule in our body that one nerve releases when stimulated in order to elicit a response and stimulate other nerves. It is responsible for the regulation of movement and emotional responses, attention, motivation and learning, and it enables us not only to see rewards, but to take action to move towards them. It is often called the happy neurotransmitter because when we have plenty of dopamine, we have feelings of pleasure, attachment, love, a sense of altruism, and integration of thoughts and emotions. Dopamine's importance in my life is evident in almost everything I do. From waking up in the morning, to having a cup of coffee, to playing guitar, to playing with my dog, and to almost everything else that is a form of personal progression or emotion. Without dopamine present in our brains, we could not structure our lives or even enjoy them. Dopamine is a catecholamine, an organic compound containing a catechol, which is a benzene ring with two hydroxyl side groups, and a side chain amine. Dopamine's basic molecular structure centers around carbon, and the big four atomic elements of life and other organic compounds are consistent in dopamine, to which carbon is the backbone of it and other organic compounds alike. Within dopamine, we can see a hexagonal arrangement of carbon atoms, the benzene ring, bonded to each adjacent carbon atom via a single covalent bond, except these three, which are double bonded. We can also see a further two carbon atoms protruding out, each with two hydrogen atoms bonded covalently to them, the second carbon of which is also bonded covalently to a single nitrogen atom, which is covalently bonded to two hydrogen atoms with two lone electron pairs left over. This is the amine group, which serves as one of the two functional groups in dopamine. At this side of the benzene ring are two oxygen atoms, each with a single hydrogen atom connected via a polar covalent bond. These are the hydroxyl groups, which are present as a result of hydroxylation, and are the other functional groups found in dopamine, responsible for the characteristic chemical reactions that take place. Here is a very simple pictorial representation of the process of dopamine synthesis in the body. The precursor of dopamine is the non-essential amino acid L-tyrosine, which commonly enters the body through the food, mainly dietary protein, we consume. An active transport mechanism takes up L-tyrosine from the bloodstream and concentrates it within the brain. Once L-tyrosine enters dopamine-releasing neurons, a series of chemical reactions take place. In the neuron, the enzyme tyrosine hydroxylase adds a hydroxyl group to L-tyrosine, which converts it into L-dopa. Finally, another enzyme called aromatic L-amino acid decarbylase removes the carboxyl group from L-dopa and becomes dopamine. So, after this process, what's left is 8 carbon atoms, 1 nitrogen atom, 2 oxygen atoms, and 11 hydrogen atoms, with a total molar mass of 153.18 grams per mole, with a melting point of 401 degrees Kelvin.